One of the things that we know is that mathematicians like to represent things in different ways. A big part of the reason for that is that often one representation is more useful than another in a certain context. One of the things that is expressed differently from time to time is the function. So functions, there's several different ways. We're having a look at 3 of them here. So the first one is the one that we're most familiar with, y equals 2x plus 3, for example. It tells us information that x and y are connected, and we can describe the relationship numerically and in words. So we can say that y is 3 more than double the value of x. That's probably the one that we're most familiar with. The next one that we're becoming more familiar with is f of x equals 2x plus 3. And, sorry, this has got the word the in here, which it shouldn't have. This tells us that f is the function that will convert the variable x, which is the thing in brackets, into 2 lots of x plus 3. And just a reminder, I'm sure you're aware of this, but just a reminder that the function can have any name. The f is just a name. We use f because that's for function, but it can be g of x, h of x, k of x, any letter of x or any other variable, for example. And they are all different functions of x. So if you've got f of x and g of x in the same question, then they are different functions, but they both have the same variable x. The one that we're least familiar with is this one. And this is actually mapping notation that went with our mapping diagram. So in our previous example, we had a look at the mapping diagram. If the mapping diagram happens to have a function that goes with it that can be described by a rule, then this is the way that that rule is presented here. And it reads like this. So the f part is the function. The colon is such that the x tells us that x is the variable. The arrow, which is quite specifically an arrow with a little stop on the end of it, tells us that x is converted to or maps to, and then whatever it maps to. So this whole thing would be read as the function such that x maps to 2x plus 3. And again, the function can have any name. So the function could be called g. So the function g that such that x is converted to 2x plus 3. It could be h, the function h, such that x is converted to 2x plus 3 or whatever. And again, all that means is they're different functions. Another term that we need to be familiar with is this idea of the value of a function. Sometimes it will be written as evaluate the function when x equals a certain number. So for a particular value of x, we substitute x into the function and find the value of y, which is equal to the function when x is a certain value. So on your tests and in your textbooks for that matter, it will turn up, questions will turn up saying evaluate the function when x equals 3, or it will say find the value of the function when x equals 3. All you do there is you substitute in x equals 3 and work out what the function equals. Very simple example here. When x is 2, the function when x is 2, so we write that in, is 2. Now this 2 is part of the original function. This is from our variable. Notice the use of brackets. It just helps keep it really straight in your head which 2 belongs to the function and which 2 belongs to the variable. And I'll give you an example in a minute of why the use of brackets is really important. So 2 times 2 plus 3 is 7. And the way that we would say that is when x equals 2, the value of the function is 7. But that means that the point 2, 7 lies on the line 2x plus 3. All right, so here's example 6.1. In fact, I'll do that in the next little video.